Good day, everyone. I am Cheryl Augustine. I am a registered chemical engineer and an advocate for environmental sustainability. And today I'll be sharing with you nanotechnology and its impact to the environment. Nanotechnology is often described as an emerging technology, one that not only holds promise to society but also is capable of revolutionizing our approaches to common problems. Well, not just common, but significant environmental problems. It has direct beneficial applications to the environment, but like all other technologies, it may have unintended risks or implications which can adversely impact the environment, both within the human body and within the natural ecosystem. While taking advantage of these new technology for health, environmental, and sustainability benefits, its environmental implications, be it positive or negative, must be rationally evaluated. Nanotechnology utilizes the unique properties of nanomaterials, which has at least one-dimensional size of a material between 1 nanometer to 100 nanometer to produce nanoscale devices, components, and systems. So as we can see here in this figure, examples of nanoscale materials within 1 nanometer to 100 nanometer are the biomolecules such as DNA, antibody, virus, glucose, protein, and many others, while nanostructures are fullerene, gold, metal oxides, polymers, to name a few. Now, if we are to compare the size of a nanometer to a bulk material or bigger materials, then we can clearly see that a nanometer is 1 billionth of a tennis ball here in this figure. So imagine how small a nanometer is. Relatively, these nanoscale materials, such as nanoparticles, have significant properties which make them unique, thus providing us several advantages. Among those advantages are the following. It has increased surface area, such as in gold nanoparticles, which are highly catalytic. And it is said that the smaller the size of a particle is, the higher or the larger its surface area is. Okay. Next, it has increased antibacterial properties and antimicrobial properties. It also has increased hardness, such as in nanocomposites, which has high surface hardness. Also, these nanoparticles have increased electron band gap, also increased electric properties and increased magnetic properties. For example, for these magnetic properties, we have the metal oxide nanoparticles, which are being used on adsorption processes and magnetic separation of pollutants from wastewater. Now, I believe these are just few of the properties or the studied properties, and I believe that there are still lots of um, properties that is yet to be discovered. What do you think about that? Now, I would like to highlight one of the significant properties of these nanoparticles, which is the increased surface area. Okay, now if we look here in this figure, a bulk material or a whole cube has a total surface area of 96 square units. But if we are to divide it into smaller particles, or if we nanoscale it into, like, for example, 4 by 4, then we'll definitely get a total surface area of 384 square units. Now for the volume, we have the same volume. And for the surface to volume ratio, then it has increased from 1.5 to 6. So definitely nanoscale materials or nanoparticles have increased surface area. Now, why are we focusing so much on this property? It is because nanoscale particles, which have a relatively larger surface area per unit mass, are said to have increased mechanical modulus and other physical and chemical properties which make them unique, and also provide greater applications or a wider range of applications. Moving on, one of the most explored nanomaterial are the carbon allotropes. Now, showing to you here in this figure are several examples of carbon allotropes with its unique molecular arrangement. Okay. Now, examples, diamond, graphite, graphene, to name a few, which I believe are the most common to us. Now, taking into example, graphite is composed of layers of carbon molecules. These are present on our pencils, and it gives us a soft material as soon as we brush it on our paper. Now, diamond also has its unique molecular arrangement, and which makes it the hardest mineral, as we all know. Graphene is composed of a single layer of carbon molecules, and if we roll the single layer of carbon molecules, then we'll have a carbon nanotube. Now, to mention, if we are to roll it once, then we'll have a single-walled carbon nanotube. But if we are to roll it multiple times, then we'll have a multi-walled carbon nanotube. So it's no longer a graphene or a graphite, it's now a carbon nanotube, which is 100 times stronger than steel, but 10 times lighter. So, this just proves that the molecular arrangement of each nanomaterial makes unique physical and chemical properties. Nanotechnology offers potential economic, societal, and environmental benefits. It also has the potential to help us reduce human footprint on the environment by providing solutions such as greenhouse gas emissions, less energy consumption, what else? Pollution. So let's see what nanotechnology can really offer. Nanotechnology has the potential to provide solutions to poor water quality. With water scarcity only expected to increase in the coming decades, then expanding the amount of clean water available around the world is really essential, right? So, nano-sized materials such as zinc oxide, titanium dioxide, tungsten oxide, and even magnetic iron oxide nanoparticles can bind to harmful pollutants, making them inert. So here in this figure, this is basically a research I found on researchgate.net, wherein the magnetic iron oxide nanoparticles were being used as an adsorbent of pollutant in order to give us a clear water or a clean water. Okay, so the iron oxide nanoparticles were being introduced to the wastewater, and then the pollutant, be it, for example, a natural colorant such as dyes, will bind to the nanoparticles, and then through magnetic separation, the nanoparticles with the pollutant will separate from the clean water. So that's just one of the wonders of the of these nanoparticles. Okay, so what I have shown you earlier is a tabletop type of research, but here in this slide, this is a larger application of nanoparticles or nanotechnology. This is basically a wastewater treatment facility. Okay, so first, the nanoparticles are being introduced to the mechanical stage, and then it goes to the biological stage, thus providing us a treated wastewater, which I believe would now be adherent to the government standards, be it Class B or Class C, depending on the standards that you follow. And I believe the application of nanotechnology is not just confined only on wastewater treatment, but also there are other emerging technologies on the improvement of water quality. So we have this molybdenum disulfide, which is being used to create membranes that remove salt from water with one-fifth the energy of conventional desalination methods. So this is just one of the emerging technologies on desalination methods. Also, other pollutants, such as oil, is being explored by our researchers. So, to date, scientists have developed nanofabrics which are capable of selectively absorbing oil. Isn't it amazing? So, together, these innovations have the potential to improve many of the world's heavily polluted waterways, hopefully. Next, nanotechnology improves air quality. Okay, so nanotechnology can also be used to improve air quality, which continues to get worse around the world every year from the release of hazardous pollutants by heavily industrial activities. However, the removal of tiny hazardous particles from the air is considered to be or is said to be technologically challenging. So nanoparticles are used to create precise sensors capable of detecting tiny harmful pollutants in the air, like heavy metal ions and radioactive elements. So one example of the nanoparticles being used are these SWNTs, or the single-walled nanotubes. So this figure, as shown on your screens, is an example of the utilization of SWNT as a sensor or as a precise sensor of N-nitrosamines. So what are these N-nitrosamines? These are um, a pollutant which can induce adverse health effects because basically it is said to be carcinogenic. Okay, so yeah. So unlike other conventional sensors which only function at extremely high temperatures, these SWNTs can detect other harmful particles such as nitrogen dioxide and ammonia gases at room temperature. All right. So what are the other applications of nanotechnology in our everyday lives? So here in this slide, we can see that these nanomaterials are being present in our consumer products. So first, we have the metal oxide nanoparticles in our sunscreen. I believe some of us here use a sunscreen, and I myself is fond of using sunscreen. So metal oxides such as zinc oxide and titanium oxide are present in our sunscreen, which basically blocks UV rays, yeah, coming from the sun. Next, silver nanoparticles are also present in our socks. So these silver nanoparticles have antimicrobial properties and antibacterial properties, which I believe are really beneficial to us, especially those who are physically active. Lastly, we have the quantum dots in our LED displays. So these quantum dots are relatively small in size and it emits different colored light depending on their size. Okay, so yeah, it is said to be present in our LED displays, say for example, on our television. Okay, so these are just some of the positive applications of nanoparticles or nanotechnology in general to our everyday lives, to us humans, and of course to the environment. So here are the other risks and impacts of nanotechnology to the environment. Now, when we say environment, it does not just talks about the natural ecosystem, but it also includes us humans. Okay. So first, nanotechnology imposes health concerns. So as we may know, these nanoparticles or nanoscale materials are extremely small in size, that it makes it possible for them to pass through impenetrable barriers allowing these nanoparticles to end up in our biological pathways, such as lymph, blood, and even bone marrow. It may end up giving us these membrane cell damage, oxidative DNA damage, DNA alterations, gene mutations, and other protein dysfunctions. So I think, and it is said that this is the most pressing concern for nanotechnology since it is a threat which imposes human health concerns because of the potential toxicity that these nanoscale materials may possess. So I just hope that this field of the toxicity of nanoparticles could be well researched or well explored in the near future. Next, nanotechnology is said to be high demanding when it comes to energy consumption during its manufacturing processes. So although nanotechnology is intended to provide a means to better manage natural resources, the nature of emerging applications and manufacturing practices may suggest otherwise. There are several studies which found out that current nanomanufacturing practices can be energy intensive, with environmental impacts highly dependent on the type of energy being used. Say, for example, the coal, nuclear, hydroelectric, and others. Lastly, nanotechnology imposes depletion of its raw materials. So the feedstocks are the raw materials needed to produce the most common nanocomponents. Other metal nanoparticles and carbon nanotubes include hydrocarbons and metal ores. So this is somewhat a pressing concern or kind of problematic because the supply of these materials is limited, and in the case of metal ores, extraction and refinement are already the cause for environmental concern. So yeah, the application of nanotechnology is really two-phased. It imposes or it gives positive applications, but there are also negative implications which could affect the environment and also us humans positively and negatively. There is no doubt that nanotechnology will continue to be developed, be of benefit to society, and continue to provide solutions to significant environmental concerns in various ways. So these nanoscale materials will be of benefit to form new products in terms of functionality, weight savings, less energy consumption, and of course, a cleaner and safer environment. But shortcomings exist when a new technology is being released. So still, engineering ethics is one of the key components to successfully apply a new technology to the environment, as well as risk assessment, which is equally important in order to evaluate potential risks. Again, this is Chanel D'Agustin, and I just hope I have made your time today valuable. So thanks so much for listening. Keep safe. Bye.